Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. In today's video, I shall do an experiment to check the refraction of light. What is refraction of light ideally? Refraction of light is the bending of light. And why does light refract? Light refracts because it changes media. Media is the plural of medium. So whenever light changes its media, it goes from a rarer medium to a denser medium or from a denser medium to a rarer medium. There are two things that happen to it. One is the ray of light bends either towards the normal or away from the normal, and second, its speed changes. So basically, refraction is defined as the bending of light when light changes media. Okay, now as you can see, I have taken this ray box and I'm shining the light, the green color light, directly on the normal. So the angle of incidence is 0. As you can see, the medium 1 and the medium 2 are same. Now where is the medium 1 and medium 2? There's a horizontal line which is drawn on the screen. That screen is the line that is telling you that above the line there is one medium and below the line there is another medium. Now over here, suppose there is the same medium existing on both the sides. So let us see what's going to happen. Well, nothing will happen. The ray of light will just keep passing through and through because there is no medium to refract it. So now, if we want to change the medium, suppose we can take the first medium as air and the second medium I can select as, say, water. So now I have a rarer medium on the top and the denser medium towards the bottom. So now what will happen when I shine a ray of light at an angle to the normal, not exactly on the normal again. So now before I do that, let me see what happens when I'm shining the ray of light exactly on the normal. When I'm shining a ray of light exactly on the normal, I find that the ray of light travels undeviated, although there is a change in medium. This again I would like to state that whenever there is a change in medium and the ray of incident light travels exactly along the normal, then the incident ray does not suffer any refraction. Neither does it suffer any reflection. So the angle of refraction and angle of reflection both are going to be 0. So now I'm going to increase the angle of incidence and see in which direction is the ray of refracted light bending. And remember, my ray of the incident ray is actually going from air to water, that is from a rarer medium to a denser medium. And after observing, we are going to make a generalization on what we observe. So when the angle of incidence is increased, what do I observe? I observe that there is always a reflected ray. So there is always an angle of incidence, and along with the angle of incidence, I also have my angle of reflection, and both are always equal. So this is fine. But what happens to the refracted ray? Now if you can see, I'll start again from here. When the angle of when the angle of incidence is increased, look in which direction is the refracted ray bending. Is it bending towards the normal or away from the normal? So here I am increasing the angle of incidence, and when I increase the angle of incidence, I find that the refracted ray, how is it bending? Is it bending away from the normal or towards the normal? It's from a rarer medium to a denser medium. So how is it bending? Just check. If you can observe carefully, this refracted ray is bending towards the normal. See, it isn't going straight into the water at the same angle 32.9 degrees. It is bending towards the normal. I can keep a protractor to show you exactly why I'm saying that. If I keep a protractor here, Ideally, if the incident ray is passing somewhere between the 30 and the 35 mark, whatever that mark is, so it should have passed along the same mark if it was traveling straight in the water. But as you can see, the ray of light is bending a little inwards towards the normal, and when I increase the angle of incidence further, what happens? Still it is not going straight. Now if I put it exactly on this 60, for example, so see, if this would have really gone straight from air to water, it would have gone through that 60 mark in air, and it would have come out straight through the 60 mark in water. But again, the ray of light in water has bent towards the normal, and therefore it is more closer to the normal than that 60 mark in water. So that means that whenever the ray of light travels from a rarer medium to a denser medium, the ray of light bends towards the normal. We can keep checking it like this. So now I'm making it 30. So let us check it. 30, does it go straight? Well, again, no, it doesn't go through and through the 30 on both the sides in air and water. So in water it is bending towards the normal, and therefore we can say that when a ray of light travels from a rarer medium to a denser medium, it bends towards the normal. And one more thing I would like to tell you, that the speed of light decreases. Why? Because the medium is denser. So always when ray of light travels from a rarer medium to a denser medium, its speed decreases and it bends towards the normal. Now exactly opposite happens when the ray of light travels from a denser medium to a rarer medium. Now observe this carefully. I have made the medium 1 the denser medium and medium 2 the rarer medium. So observe what is happening to the ray of light when it is passing from a denser medium to a rarer medium. Meaning, is it bending away from the normal or towards the normal? So let me put it on the 30 mark. So as you can see, when the ray of light is traveling along that 30-degree mark, whatever it is not continuing along the 30-degree mark on the other side. Rather, it has gone beyond the 30-degree mark. Meaning, when the ray of light travels from a denser medium to a rarer medium, it bends away from the normal, and the speed of light also increases. Let me check with another value of the angle of incidence. Suppose I try again with a ray of light that is passing through the 60 mark. Well, what I can see is it is showing you the phenomena of total internal reflection. So let me put it on something like maybe, okay, this. So here again we find that the ray of light is bending away from the normal and not going straight through and through from water to air. So this shows that when a ray enters from a rarer medium to a denser medium, it bends towards the normal and its speed decreases. And when it goes from a denser medium to a rarer medium, it bends away from the normal and the speed of light increases. So this is all on refraction of light when light passes from denser to rarer and rarer to denser medium. And please, you yourself can try this simulation on PHET. I'm a big fan of PHET, so you'll get a lot of simulations to try your hands on, and that will clear your concepts. So a big thanks to the PHET for allowing me to use their simulations. Well, all of you can use the simulations. It's not only that I've got the rights to use the simulation, but I'm thanking them because I've used the simulation to make concepts more clearer, because every time it's not possible for children to go to the lab and perform experiments. So you can use this PHET simulation for studying your refraction concept. So that's all in today's video on refraction of light. And if you like watching my video, please do subscribe to my channel. Thank you.